Hello everyone, we're going to be doing section 7.6, which is the double angle and half angle formulas. So we have three objectives. One, we want to use double angle formulas to find exact values. Two, we use double angle formulas to establish identities. And three, use half angle formulas to find exact values. So first, I just want to review, here's the summary of the double angle formulas. So we have sine of 2 theta is equal to 2 sine theta cosine theta. Cosine of 2 theta is equal to cosine squared of theta minus sine of squared theta. Cosine 2 theta can also be equal to 1 minus 2 sine squared theta. And cosine 2 of theta is also equal to 2 cosine theta minus 1. So we have one single formula for sine of 2 theta, but we have three separate formulas for cosine of 2 theta, which we can choose whichever one we want to use, whichever is going to be most convenient to us. All right, so objective one, we just want to use the double angle formulas to find exact values. So example one, if sine of theta is equal to 3/5, where theta is between pi over 2 and pi, not including pi over 2 and pi, find the exact value of sine of 2 theta and cosine of 2 theta. So if we already know sine of theta, and we want to find sine of 2 theta and cosine of 2 theta, first, let's just identify what we need for sine of 2 theta. So for sine of 2 theta, we know that this is going to be equal to 2 sine theta times cosine theta, which means that we would need to find cosine of theta. We already have that sine of theta is equal to 3/5. So we need cosine of theta. So what we're going to do is use the fact that sine of theta is equal to y over r, where y is our y value and then r is our radius. So we get that y is equal to 3 and our radius is equal to 5. Then once again, we want to use our equation for a circle to find our value of x. So for our equation for a circle, remember, was x squared plus y squared is equal to r squared, where in this case, we have y is 3, so we have 3 squared is equal to r squared, which this simplifies to x squared plus 9 is equal to 25. We subtract 9 from both sides. We get x squared is equal to 16. Then since we have that x squared is equal to 16, we know that x has to be equal to positive or negative 4. Since we're considering theta between pi over 2 and pi, this means that our values of cosine are going to be negative since our x values are negative. This meaning that x has to be negative 4. So we say x is equal to negative 4 since cosine of theta is less than 0 for theta between pi over 2 and pi. So now we have our value of x. This means that cosine of theta, which is equal to x over r, is equal to negative 4 over 5. And now we can use our double angle formula. Use our double angle formula. Specifically for sine of 2 pi, but also theta, I meant theta, not pi, but also for cosine of 2 theta as well. Since we only needed sine in one case, we could have just used our values of sine right away to find cosine of 2 theta. But now we have cosine and sine, so we could use any one of our different equations. So let's start with sine of 2 theta. So sine of 2 theta is equal to 2 sine of theta times cosine of theta, which means that this is going to be 2 times 3 over 5 and negative 4 over 5. When we multiply these values together, 3 times negative 4 is going to be negative 12. So we have negative 12 over 25. We multiply 2 times negative 12. This gives us negative 24 over 25. So sine of 2 theta is equal to negative 24 over 25. Now we want to find cosine of 2 theta. Since we already knew our value of sine, we're just going to go ahead and use the equation that only involves sine. This means that we could have done this in the beginning or at the end. If you wanted to find cosine of 2 theta immediately, you could have found that value first and then done everything else to find sine of 2 theta. You can now use any one of the equations. So we already knew sine of theta was equal to 3/5. But now we know cosine of theta is equal to negative 4/5. So we can use any equation. But let's go ahead and use cosine of 2 theta is equal to 1 minus 2 sine squared theta. Then this will give us cosine of 2 theta is equal to 1 minus 2 of 3/5 squared. So 3/5 squared is going to be 9 over 25, which then 9 times 2 is 18. So we have 1 minus 18 over 25. We know 1 is the same thing essentially as saying 25 over 25. So 25 minus 18 is going to be 7 over 25. So cosine of 2 theta was 7 over 25. So those are the exact values of sine of 2 theta and cosine of 2 theta. Moving on to our next objective, we have objective 2, which is use double angle formulas to establish identities. So the double angle formula for tangent is going to be tangent of 2 theta is equal to 2 tangent theta divided by 1 minus tangent squared theta. We can also rearrange our double angle formulas for sine and cosine to get new and useful identities. We can now get that cosine squared of theta is equal to 1 plus cosine of 2 theta, all divided by 2. Sine squared of theta is equal to 1 minus cosine of 2 theta divided by 2. And tangent squared of theta is equal to 1 minus cosine 2 theta divided by 1 plus cosine of 2 theta. So now we have these new identities. And for example 2, we want to solve sine of theta times cosine of theta is equal to negative 1/2 for theta between 0 and 2 pi. So if we're looking at our equation here, sine of theta times cosine of theta is equal to negative 1/2. If there were a 2 in front of sine of theta cosine theta, this would look almost exactly like sine of 2 theta. But what we can actually do is that we can actually turn this equation into 2 sine theta times cosine of theta. If we just multiply each side by 2, this would then give us equal to negative 1. So let's go ahead and do that, which then we can replace with sine of 2 theta. So sine of theta times cosine of theta, if we multiply by 2, would give us sine of 2 theta. So let's multiply each side by 2. If we multiply each side by 2, this is now going to give us 2 sine theta times cosine theta is equal to -1, which then we can replace 2 cosine theta times 2 sine of theta times cosine theta with sine of 2 theta. So here I have that sine of 2 theta is equal to -1. So if we want to solve this equation for theta between 0 and 2 pi, we should write out our general formula. So we can say we have to write our general formula. That gives all solutions to this equation then list the ones in the correct interval. Which in this case, our correct interval would be from 0 to 2 pi, not including 2 pi because 0 and 2 pi would be the same value essentially. So then we have that since sine of 3 pi over 2 plus 2 pi k gives us -1 for an integer k, for 2 theta, we can get, and we're going to simplify. So we're stating that 2 theta is equal to 3 pi over 2 plus 2 pi k. Well, if we just want to do theta, we can divide each value by 2, and this now gives us theta is equal to 3 pi over 4 plus pi k, where k is an integer. And now we have to actually find solutions for this equation that is going to fit into our interval from 0 to 2 pi, not including 2 pi. Our most common and probably most useful values of k are going to be k is equal to -1, k is equal to 0, k is equal to 1, k is equal to 2. Sometimes it might be 0, 1, 2, 3, or it might be -2, -1, 0, 1, which you'll probably have to fiddle around with that a little bit just to find which values are actually going to fit into the interval. But for our case, let's just be broad and do -1 to +2. So if we start with k is equal to -1, this means that theta is equal to 3 pi over 4 plus pi times -1. It's going to give us -pi. So we have 3 pi over 4 minus pi, which that is going to leave us with a -pi over 4. -pi over 4 is not in our unit circle. So it's not going to be one of our values, but we'll go on to our next value, k equal to 0. Then we're going to get theta is equal to 3 pi over 4 plus pi times 0. So we just get 3 pi over 4. So then we have 3 pi over 4 plus 0, which is 3 pi over 4. And we know that 3 pi over 4 is in our unit circle. So this is going to be one of our solutions. Then on to our next value, k equals +1. we'll get theta is equal to 3 pi over 4 plus pi times 1, which gives us 3 pi over 4 plus pi, which pi in this case is the same thing as saying 4 pi over 4, which would then leave us with a 7 pi over 4. And this value is contained in our unit circle as well. So it's also a solution. Then last, let's try out k equals 2. This will give us theta is equal to 3 pi over 4 plus pi times 2. So we have 3 pi over 4 plus 2 pi, which this is going to end up giving us 11 pi over 4, which is greater than 2 pi, so it is not contained in our unit circle. So this means that the solutions in the interval 0 to 2 pi are going to be theta is equal to 3 pi over 4 and 7 pi over 4. If we want to write out our solution set, we know that our solution set is going to be equal to curly braces 3 pi over 4, comma 7 pi over 4, and curly braces. All right, so we found the values of exactly sine of theta cosine theta is equal to -1/2. We did this by just trying to manipulate our equation as much as possible to replace it with an identity, and then using that identity to go ahead and find our solutions.